All right, let's get into it. Today we've got a really great story from the world of home labs, and it's all about tackling one of those super common, pull your hair out kind of problems, but with a solution that, at first glance, just looks completely insane. Total overkill. But trust me, as you're about to see, it's actually pretty brilliant.
So, if you run a home lab, especially with Docker apps, I bet you've been here. You've got your whole setup humming along. Plex, Sonarr, Home Assistant, the works. Everything's perfect. And then one day, boom, it just self-destructs. The database gets corrupted, and you're stuck trying to figure out what went wrong and how to fix it. So, what is going on here?
And yeah, this quote from the original post it absolutely nails the feeling, right? It's not like things slowly get worse. No, it's a sudden, catastrophic implosion. One minute you're streaming a movie, the next your whole media stack is just gone. And it's that randomness, that unpredictability that we're going to tackle today.
Okay, so let's dig into the actual core of the problem. And almost every single time, it all starts with this really toxic relationship between two technologies that just should never, ever be put in the same room together. SQLite and NFS, the network file system.
And this really breaks it down perfectly. Think about what SQLite needs to be happy. It's the little database engine that powers so many of our favorite apps, right? It needs two simple things: super fast access to the file, like zero delay, and totally reliable, rock-solid file locking. It needs to know that when it locks a file, it stays locked. But what does it get when you stick it on an NFS share? The complete opposite. You get network lag you can't predict and file locking that's, well, let's just say it's flaky at best. It's basically a guaranteed recipe for corrupted data.
So, okay, if NFS is the villain here, who's the hero? Well, this is where this story gets really, really interesting. The solution that comes to the rescue is Ceph. And I'm sure for some of you, the moment I said Ceph, you probably did a double take. Like, Ceph? For a home lab? Seriously?
Exactly. I mean, Ceph is an absolute monster. It's an enterprise-grade, software-defined storage platform. This is the kind of thing you find running in massive data centers. The common wisdom is that you need tons of RAM, crazy expensive enterprise SSDs, and a super fast network just to get it to boot up. It's basically the Formula One car of storage. So the question is, how in the world are you supposed to park that in a home lab garage?
Well, check this out. This is how. We are not talking about giant rack-mounted servers. We're talking about 5 of these tiny little HP EliteDesk mini PCs. You know, the kind of thing you'd find in an office. And get this, each one has just 16 gigs of RAM, a regular off-the-shelf consumer NVMe drive, and it's all connected with plain old 1 gigabit Ethernet. I mean, this setup basically spits in the face of everything you're supposed to do with Ceph. And here's the punchline, the twist in the story. It worked. Not only did it worked perfectly. This completely underspecced, rule-breaking cluster solved the whole SQLite nightmare for good. So, that leaves us with the million-dollar question. How? How did they get away with it?
Yeah, this whole thing is really a masterclass in busting some of the biggest myths in the home lab world. It really makes you question that old idea that you absolutely have to have expensive enterprise gear to get enterprise-level reliability.
And this is always the first question that pops up, right? Don't you need like 10 gig networking and those fancy enterprise SSDs? I mean, if you read the official docs for Ceph or even Proxmox, they practically yell at you that trying this on anything less than 10 gig is just asking for trouble. So, what's the deal?
The secret? It's not really about the hardware at all. It's about a fundamental shift in thinking. It all comes down to one single core philosophy that changes everything.
And here it is. Know your workload. See, this person wasn't trying to run a dozen high-performance VMs or edit massive video files. The actual workload was tiny. It was just a bunch of container config files and those little SQLite databases. That stuff doesn't need insane speed. What it desperately needs is consistency, reliability. It needs that rock-solid file locking that we talked about, which, it turns out, is something a distributed file system like Ceph is naturally amazing at.
And this chart just lays it all out, myth versus reality. The myth, you need 10 gig networking, minimum. The home lab reality, for this kind of light I/O, 1 gig is totally fine. The myth says you need those super expensive enterprise SSDs with all the bells and whistles. The reality, A decent consumer NVMe is perfectly capable when you're not hammering it with writes all day. And yeah, same for RAM. You don't need 64 gigs per node when you're just running a few lightweight containers. And hey, don't just take my word for it. This isn't some fluke. Here's a quote from another Homelabber who did basically the same thing. They ran standard Samsung NVMe drives in a low I/O setup for 2 whole years and saw pretty much no wear issues. So yeah, this actually works. Okay, so if we're not building this for mind-blowing speed, then what's the big prize? What's the payoff for all this effort? Well, that brings us to the real superpower of this setup. It's not performance. It's resilience. And you know what's crazy? The way you actually use it is so simple, it's almost beautiful. You just set up the Ceph file system, CephFS, you mount that one shared folder on all of your computers running Docker, and you just point your container volumes to that folder. That's literally it. Your apps now have stable, shared storage. Goodbye NFS, goodbye corrupted databases. And this really is the key takeaway. The point of this whole project was never about getting the highest score on a speed test. The goal was to build a home lab that just doesn't die. The real prize here is high availability. It's that peace of mind, knowing your stuff is going to stay up and running, even if a piece of hardware decides to give up. I mean, think about it. With a normal setup like a single NAS box running NFS, that box is your single point of failure. If you need to reboot it for an update or a power supply dies, every single one of your apps goes down with it. Kaput. But with a Ceph cluster like this, there is no single point of failure. If one of those little mini PCs just dies completely, the cluster doesn't care. It just keeps chugging along, heals itself in the background, and your apps, they don't even blink. That's not just an improvement, it's a total game changer. So, after all that, what are the big lessons we can pull from this awesome experiment? Let's try to boil this down into some advice you can actually use if you're thinking about making your own home lab a little more bulletproof. Number 1, and this is the big one, know your I/O patterns. Build for what you actually do, not for what you might do. Second, for the love of all that is holy, stop putting databases on NFS. Just don't. It will end in tears. Third, if you're going to dip your toes into this, CephFS is the perfect place to start for lighter stuff. A really good pro tip. Even if you're only on 1 gig Ethernet, try to keep your Ceph traffic on its own network. It helps. And yeah, we've seen that reliable consumer SSDs can totally work. But last, and this is the golden rule, I don't care how awesome your setup is, backups. Always, always, always have backups. No excuses. You know, when you take a step back, a project like this is more than just a neat trick. It's part of a bigger, kind of quiet revolution that's happening right now, the democratization of enterprise tech. All this powerful stuff that used to be locked away in corporate data centers is now becoming accessible to everybody. Hardware is getting cheaper, software is open source, and so you have people building these incredible, resilient mini data centers in their closets. It's amazing. And that really just leaves us with one final and, I think, really exciting question. If we as a community can figure out how to tame a monster like Ceph and run it on a few tiny PCs, what's the next impossible thing we're going to conquer? What other big, complex, enterprise-level tech is just waiting for the Homelab community to get its hands on it, break it, and then rebuild it for everyone? Man, what a cool time to be a tinkerer.